What's going on? Back again for another video. This time we're going to look at finding derivatives of exponential functions. All right, so let's take a look at the two formulas we have here. We have the derivative of b raised to the u. Now the exponential function, your variable is up here in the exponent. Now here we have some base b. So the derivative is b to the u, okay, just whatever the problem is, it's b to the u times the natural log of the base times the derivative of the exponent. All right, and then we have the derivative of e to the u. Well, that's just e to the u times the derivative of the exponent. Now, keep in mind, whenever you're finding derivatives of exponential functions, most of the time you're going to be dealing with e raised to a power, this one down here. Okay, I'm not saying you're not ever going to come across this, but the majority of the time it's going to be e to a power. We're going to do an example of this one, but most of the problems are e to a power. So, you know, you just follow the formulas. So let's go ahead and get started. All right, so find the derivative. So we got y equals e to the x. So this is going to be y equals e to the x times the derivative of the exponent. Well, what's the derivative of x? It's 1, right? So times 1. And so 1 times e to the x, that's just e to the x. And a lot of books in there, a lot of books have another formula in there. I mean, we've got e to the u, you know, just whatever the exponent is. It's just e to the u times the derivative of the exponent. But a lot of books will have this formula here, where it's just e to the x is just e to the x. Okay, I would just remember that. So, you know, there's no need in writing that times 1 there, because 1 times e to the x is just e to the x. So just remember, the derivative of e to the x is just e to the x. All right, so let's look at this one. Y equals 2 to the 4x. So let's just go ahead real quick and write down our formula. Okay, I just wrote the formula here so we don't have to scroll back up. All right, so we've got y prime is, okay, so we've got 2 to the 4x, so it's just 2 to the 4x, 2 to the 4x times the natural log of the base, and the base here is 2, times the derivative of the exponent. Say the derivative of the exponent. So the derivative of 4x is 4. And we can write this, we can clean this up some. Now notice this 4 times 2 to the 4x. This is not 8 to the 4x. You can't multiply the 4 and the 2. But what we can do is we can write the 4. So I'm rewriting the 4 as 2 squared times 2 to the 4x times the natural log of 2. And then what happens when you have like bases and you're multiplying? So that's going to be 2 raised to the 2 plus 4x times the natural log of 2. Remember, when you're multiplying like bases, you add the exponents. And so this is your answer. All right, let me go up here and circle this one too. All right, so hopefully that makes sense. All right, let's look at this one. So this one has quite a bit in it. This is going back to what we've done in the previous videos. We've got a logarithm, we've got trig function, and we've got e to a power. All right, so let's just go through this and see what we get. So we're taking the derivative of the natural log. So do you remember what the derivative of natural log is? Well, the derivative of natural log, whatever you're taking the natural log of, that goes in the denominator. And then what goes in the numerator? The derivative of what you're taking the natural log of. So in the numerator, we've got to put the derivative of cosine e to the 2x. So what's the derivative of cosine? Negative sine times the derivative of what you're taking the cosine of. So what's the derivative of e to the 2x? Well, that's just e to the 2x times the derivative of the exponent. All right? So all I did for the numerator is took the derivative of cosine e to the 2x. The derivative of cosine is negative sine times the derivative of what you're taking the cosine of, which is this e to the 2x times 2. And so this is going to give us negative 2 e to the 2x times tangent of e to the 2x. All right. So think of it like this. I've got my negative 2 e to the 2x. That's this part right here. And then sine over cosine is tangent. And so this is our answer. All right. Just go through it step by step. Okay. Don't let it confuse you. All right. So how about this one? Well, for this one, we've got product rule, don't we? We've got this function times this function. X is our first function. E to the tangent x is our second function. And so I get y prime. Remember the product rule. Derivative of the first times the second plus the derivative of the second times the first. So the derivative of the first function is 1. Derivative of x is 1 times the second function plus the derivative of the second function. So I've got to take the derivative of e to the tangent x. Well, that's e to the tangent x times the derivative of the exponent. So what's the derivative of tangent? It's secant squared. So this is the derivative of the second function, and then times the first function, so times x. And so that's going to give me y prime is e to the tangent x times 1 plus x secant squared x. All right, so what happened there? Well, for this one, all I did is I factored out this common factor of e to the tangent x. And you can see when I factor it out of here, I'm left with a 1. When I factor it out of this one, I'm left with the x secant squared. All right. And you want to, I would recommend whenever you're finding derivatives and you have that e to a power, and you have a common factor of that e to a power, go ahead and factor it out. Okay? All right. All right, so how about this one? We've got y equals e to the 1 over x, and then all of that is squared. So the first thing I'm going to do is write this as e to the 2 over x. So remember, when you have this, what do? You multiply exponents. Remember your exponent properties, a to the m, all that raised to the n is a to the m times n. That's the property I used to go from here to here. So 2 times 1 over x is just 2 over x. And so now I have y prime is e to the 2 over x times the derivative of the exponent. And what's the derivative of this? Negative 2 over x squared. All right. So let me talk about this a little more. I think I may have talked about it in earlier videos. I honestly can't remember. If I did, then you're going to hear it again. If not, then I think it's good for you to hear this. Remember, when you have 1 over x, okay, the derivative of 1 over x is negative 1 over x squared. Okay, remember how to get that. So the 1 over x, I can write that as x to the negative 1. And then if I use the power rule, that's negative 1 times x to the negative 2. Move this to the denominator. So that's negative 1 over x squared, because when you move it across the fraction bar, it changes the sign of the exponent. So the derivative of 1 over x is negative 1 over x squared. And, you know, you could have some number up here other than 1, a 2, a 3, a 4, a 5, whatever. Let's just say it's some constant c. Okay, this would be a c right here, c. It would just be that constant term negative that constant term over x squared. That's one that I would just memorize. It comes up quite a bit throughout calculus, taking the derivative of 1 over x or some number over x. So I would remember it. What that's going to do is just going to save you some time from having to do these steps here. It's going to, you know, you won't have to move the x up and then do all that power rule. Just remember, if you have some number over x and you're taking the derivative, it's negative whatever that number is over x squared. Okay, and if you don't remember it, if you forget it, then you can go through this process right here to find the derivative. Okay, all right. So that's how we did the derivative there of 2 over x. And so now I get y prime is going to be negative 2e to the 2 over x squared. All right, I just multiplied these two. All right, let's look at another one. All right, so what do we have? What do we have here? Here we have the chain rule. So I've got y prime equals, see how I have all of this in parentheses raised to a power? So that's going to be 3 times 3e to the 4x plus 4x squared natural log x, and then all of that squared. Okay, so what did I do? I'm just doing the chain rule. The 3 comes down, subtract 1 from the exponent. And then remember what the chain rule says. And then it's times the derivative of what's inside the parentheses. All right, so the derivative of what's inside the parentheses, that's going to be 3e to the 4x. I'm taking the derivative of this term. So it's 3e to the 4x times the derivative of the exponent. So the derivative of 4x is 4 plus, and now the derivative of this thing right here, of this. Here I've got to use product rule. See how I have 4x squared, that's one function, and natural log x is another function. All right, so that's product rule. So it's the derivative of the first, 8x, times the second function, plus the derivative of the second function, the derivative of natural log x. Whatever you're taking the natural log of, that goes in the denominator. The derivative of that goes in the numerator. Derivative of x is 1, and that's times 4x squared. All right. So the 3 comes down, subtract 1 from the exponent. And then all of this right here is the derivative of what's inside the parentheses. And so I get y prime is going to be, let's see, that's going to be 3 times 3e to the 4x, to the 4x plus 4x squared natural log x squared times, and so let's clean this up. That's going to be 12e to the 4x plus 8x natural log x plus 4x. X squared and x cancel, leave me with 4x. And I mean, you know, if we wanted to, we could factor a 4 out. Let's just go ahead and do it for the fun of it. So if I factor out a 4, see, I'm factoring out the greatest common factor of the 12, the 8, and the 4. Okay? And so if I factor a 4 out, 4 times 3 is 12. 3e to the 4x plus 4x squared, natural log x, all of that squared, times, all right, so that's going to be 3e to the 4x plus 2x natural log x plus x. And there's your answer. All right, so, you know, if you're in my class watching this, I mean, this is acceptable also, but, you know, if you think about it, go ahead and factor that greatest common factor out. Just make this, try to make your expressions here as simple as possible, you know, if you can. All right, I think this is the last example. It says, find the slope of a line tangent to the curve y equals 3e to the 2x over x squared plus 1, where x is 1.275. All right, so let's just write the problem down. 3e to the 2x over x squared plus 1. All right, so to find the derivative here, we need to use the quotient rule. And so y prime, the quotient rule, says what? The derivative of the numerator, which is 3e to the 2x, times the derivative of the exponent, so times 2, times the denominator. Okay, so this right here is the derivative of the numerator times the denominator minus the derivative of the denominator, so the derivative of x squared plus 1 is 2x, times the numerator, 3e to the 2x, over the denominator squared. All right, so let's just go ahead and do one more step here. We've got 6e to the 2x times x squared plus 1 minus 6x e to the 2x over, and that's going to be x squared plus 1 squared. All right, so let's look at this. Whoop, accidentally hit something there. So we've got y prime is 6e to the 2x times x squared plus 1 minus x. All right, so what did I do there? Well, I have a common factor of 6e to the 2x. So I pull that out, and if I pull that out, you can see I'm left with x squared plus 1, that's this, minus, and then here I'm left with x. Okay, and that's going to be x squared plus 1 squared. And so, I mean, you don't necessarily have to do this, but I'm gonna go ahead and do it. X squared minus x plus 1. I just rewrote this in descending powers. And so that's x squared plus 1 squared. And then what did they want us to do? They wanted us to evaluate it when x is 1.275. So y prime of 1.275 is equal to 6e to the 2 times 1.275 times 1.275 squared minus 1.275 plus 1 over 1.275 squared plus 1, and then all of that squared. And when you plug all that into your calculator, you get about 15.05 as your answer. All right, so there you go. That's the video. Just remember, whenever you're finding the derivative of e raised to a power, it's just e raised to that power times the derivative of the exponent. And that's all it is. All right, so I hope this video helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I'll see you in the next one. Later.